In this video, we're going to take the line integral of f of xy equals x over y plus 1 over the curve C, which will be the lower half circle of radius 2 centered at the origin. Not that you need a picture of this, but let's go ahead and just draw in x, y, so 2 units away. Our curve will start here, go like that. And so a basic parameterization of this curve would be x of t is 2 cosine t, y of t is 2 sine t, and t goes between, well, pi and 2 pi. I think that's all we really need from that picture, so let's call that done. And then the other thing is we're going to then take a look at this integral is going to call for finding out what dx dt is, so negative 2 sine t, and what dy dt is, so 2 cosine t. So when we set up this integral over C of f of x, y, ds, this will be an integral with t bounds from this pi right here to 2 pi, so pi to 2 pi of f, but we need to rewrite f in terms of t, so take this x over y plus 1 and instead write 2 cosine t for the x over 2 sine t for the y plus 1, and then the ds here is going to turn into square root negative 2 sine t squared plus 2 cosine t squared dt. Of course, this whole thing, just to a basic trig identity, is going to simplify just down to the number 2, and beyond that we won't finish this integration, though of course it's just a basic substitution. The other integrals here, though, such as this integral over C of f of x, y, dx, same basic idea, same t-bounds, same function, so you still replace x here with 2 cosine t and replace the y there with 2 sine t. So 2 sine t plus 1. That's all the same. It's just that instead of a ds getting replaced by this square root and dt, dx is just replaced with dx dt, so this negative 2 sine t and a dt. The integral, finally, with respect to y, so is equal to integral pi 2 pi, same thing here, 2 cosine t over 2 sine t plus 1, and then finally the dy gets replaced with 2 cosine t dt. Now I'd like to just do one more example just to illustrate something that's used for just compact notation a little bit. And so you'll see something like this, so I'm going to have to change the function on you, though I don't want to change this function by too much. So what would be the integral over the same c, but I'd like to look at x over y plus 1 dx plus y plus 1 over x dy. So I'm just using the reciprocal just because this will make things easier. We get to keep a lot of the work we've done. This is just shorthand notation used for, really you could just think of it as there being another integral sign here. So I'll just do this sort of the quick way. This is just convenient notation to mean this, and so if we just put in all the pieces, this will turn into integral pi to 2 pi. I mean, there's just two separate integrals that you do the same way. In this example, that x here turns into 2 cosine t over the y turns into 2 sine t, and then we still have that plus 1. The dx we saw earlier right there, negative 2 sine, t dt, plus, and then we need this second integral, which I'm running out of room for. Let me just kind of shift everything over a little bit. Plus, for this second integral, same, I mean, just like setting this up, we still have an integral from pi to 2 pi for t. It's just that we have y plus 1 now, so we've got 2 sine t, then finally a plus 1, and then the x is 2 cosine t, and then the dy gets replaced with, where is it? So dy turns into 2 cosine t, so 2 cosine t times a dt. I'm not claiming that all of the integrals that we've set up here are going to be easy to solve by hand. Hopefully you see which ones are and which ones aren't. Certainly the integral that was here before, this integral right here is nice to solve, and the rest of these might be a little bit of a mess.